Okay, so this podcast is going to be all about atoms, the structure of the atom, but also atomic theory, which tells us about what we think the atom is composed of and how it looks and everything. But also, I want you to understand a little bit of the history of atomic theory and understand how our ideas about the atom have changed. These notes are going to go on page 45 in your notebook, and if you want to set it up Cornell style, and then we're going to talk about some individual people who had different ideas about the atom. You might want to put their names on the left column, and then you can write down what they said about the atom on the right side, and that'd be a good way to organize your notes. Okay, so from very, very early on, we're talking about 400 BC here, people had an idea about what matter is made of. So we haven't yet talked really about what, I keep saying the word particles, but I haven't told you what those particles are. And so now this is the first time we're really going to talk about that. But from early on, people wondered what things were made of. And this fellow Democritus in 400 BC had the idea that everything, all matter, is made of teeny little pieces that can't be divided into anything any smaller. So if you had a piece of cardboard or a piece of rubber or the leaf on a tree, you could cut it up until it was so tiny you couldn't cut it anymore, and that he called atomos. I think it's kind of amazing that that long ago that people really were thinking about larger objects being made of smaller objects is really kind of amazing. But his idea was that if you have a different kind of matter, you have a different atomos, or in other words, a different little particle that made it up. For instance, if you had a smooth object, like a smooth rock, the atomos, or the atoms that make up that rock, would also be smooth. Or if you had something sharp or pointy or prickly, then the atomos, or the atoms that make up that sharp object or spiky object, would also have that shape to them. That was his idea. He also said that the atomos are in constant motion, that they're moving all the time, and it, like I said, really amazes me that long ago, 400 years before we started our timeline, so we're talking about, gosh, 2,500 years ago, this fellow was right that they are in constant motion. He was right about that. He was right that there are different types of atomos in different types of matter, although they aren't pointy and smooth and stuff, but he did know about that. And he did know that larger objects are made of smaller objects. Really, truly amazing. But of course, his idea of what matter is made of was only partially correct. And so we're going to go on to the next fellow that sort of added to our theory of the atom. Okay, fast forward to 1802, which was a couple of hundred years ago. So for a long time we didn't really know much of anything different than what Democritus originally said. But in 1802, around 1802, this man John Dalton was also working on this idea of the atom and trying to understand it. And he developed the idea that atoms can form new substances by becoming rearranged somehow. He also said that atoms are hard spheres, like a marble. So that's what he imagined them to be. They're all the same little hard spheres, but they're actually different in some way for each element. For instance, similar to the fact that these marbles are all different, he would say the same were true of different kinds of atoms, that they might be different colors, I imagine, or different sizes maybe. He was right, though, in this first point. Okay, he wasn't so right about the atoms being hard like a marble, but he was right that atoms can be rearranged to form unique substances. And you have already learned that when you combine elements, you can form a compound, and that's exactly what he was talking about. So John Dalton gave us this idea of atoms being rearranged, and also that each element might have a slightly different atom. But now we're going to talk about the next fellow that was involved in our understanding of the atom. Okay, now we're moving ahead another 100 years. More research is done. People begin to understand more. And of course, technology improves. Technology changes. And as we have new technologies, we can gain new information. So J.J. Thomson was the next fellow we'll talk about in 1906 or around about 1906. He discovered, or through his research discovered, that atoms have different charges in them. He discovered that doing different experiments that there was a negative charge in an atom and a positive charge in an atom. So that all matter is made up of these tiny particles that we call now atoms, and that each atom has these charges in it. So his model of what an atom might look like is this one, where it's a sphere, and embedded in the sphere are some positive charges and also negative charges. Okay? So in this model here, the sort of the orange-red color would be the positive part, and then those little blue dots would be the negative part. So I kind of like to call it the chocolate chip cookie model of the atom. So think about the cookie itself being the positive charge and those delicious chocolate chips being the negative charges. Now, J.J. Thomson was not incorrect. Atoms do have negative and positive charges, but his idea of a chocolate chip cookie model, in other words, having the negative charges embedded in the positive charges, was not exactly correct. Okay, so you can see that over time we learn new pieces of information and our understanding improves a little bit at a time, but there's always some incorrect information in every model along with all the correct information. And so you can see that this is a good way of understanding how science progresses. This is an example of how science progresses little bits at a time, each individual and each piece of the model coming together. Okay, now around that same time, only very few years later, and actually I think Rutherford and Thomson did work together, I think. I think Rutherford was Thomson's student, but I can't remember. But anyway, it was around that same time. This other man, Ernest Rutherford, did more experiments and began understanding even a little better about the structure of the atom, what all matter is made of. And he discovered that the atom's mass, in other words, its weight, or its, the stuff that makes it up, mainly is contained in the center of the atom. And he called this area the nucleus. I know last year you learned about the nucleus of the cell. This is the same idea. It's kind of in the center. Although the nucleus of a cell isn't always in the center, but it's kind of like the center of the atom. He also discovered that the nucleus is positively charged. So rather than thinking about the atom as like a chocolate chip cookie with positive charges all around, in fact, what Rutherford found out is that the positive charge is all in the middle, and that there are little tiny particles that are even smaller than the atom itself that are in the nucleus that carry the positive charge. And these little particles we call protons. This is extremely important. Make sure you write this down. Protons are positively charged, and they're found in the center of the atom, and they're part of what make up the mass of an atom. He also discovered that the atom's negative charge is found outside that center area, way outside where the mass is found, and that these negative charges are due to this small particle that he discovered called an electron. So electrons, extremely important, electrons are negatively charged, and protons are positively charged. And this was discovered by this fellow here, Ernest Rutherford, and his model looks like the one shown up here. It is the nucleus with a positive charge in the center, and then outside the nucleus, these negatively charged electrons. So now we don't just have a tiny little atom, atomos, we instead have an atom that's made of even smaller pieces, protons and electrons. But this isn't exactly our current today model of what an atom looks like. This was only one step along the way. Since Rutherford's time, we have discovered that through some other experiments and some other individuals, we have discovered that, first of all, atoms are mostly empty space. So if you could look at an atom, the majority of that atom by far would be just space. The nucleus would be at the center, and then there would be vast amounts of space until you get to the electrons. We also now understand that the electrons are in specific regions outside the nucleus, certain areas that we used to think were like the orbits of the planets. In fact, they were called orbits. But we now know that the electrons are free to move within a range of space, and they're moving so fast, you really can't tell at any moment where they are. They're moving at extremely high speed. You can't really even pinpoint where they are. But they are in specific regions, and we call these clouds. So we now know that the electrons are outside in a cloud. The other thing that we have discovered over time is that the nucleus is not just protons, that there are other tiny little neutral particles, not charged at all, they're not negative or positive, they're neutral, that they're also in there in the nucleus, and they're called neutrons, and they also contribute to the mass. So the nucleus, instead of being just a circle in the middle of the atom, instead we now know it's composed of positively charged protons and negatively charged neutral charged neutrons. And then outside, way out here in the cloud, will be the negatively charged electrons. So our modern model of the atom might look something like this, although this is very, very simplified version. But our modern model will have the nucleus at the center of the atom, and you might want to draw this in your notes, but the nucleus at the center of the atom containing both protons, which are positively charged, and neutrons, which carry no charge. I usually write that as a 0. And they're in the center, and they make up the mass of the atom. So if we had to say that, we would say over here that this is the mass of the atom, and we'll get to that more later. And then outside, somewhere out in the outer regions beyond the nucleus, we have the electrons, which are negatively charged, zooming at high speed. And really, if we could see them, they might look something more like that, where it's just a cloud of electrons. They're just zooming at super high speed, and you can't really pinpoint exactly where they are. But this is what we would call our current model of the atom. Something similar to this. And remember, this model has been developed over hundreds and thousands of years with a lot of different scientists and a lot of different very smart men and women contributing new ideas and new technologies all the time until we can begin to develop this current model. And the reason for this, of course, is that atoms are too small to see. So we can't really say that this is exactly what the atom looks like. They're way too small for us to see with our eyes. So we develop a model based on what we know, and that helps us to understand it. And like I said, little by little, our model changes, but always building on the previous knowledge, and that's how science works. Okay, so that's all I have for you for this lesson. And I'm going to check these notes, remember, on Tuesday. They should have been written, hopefully, on page 45. And just to reward those of you who are really, really, truly listening to the podcast and not just copying someone else's notes, here's what I want you to do. Okay, I want you to write at the very top of your notes page, right at the very top in the middle of the page, and I want you to write it in all capital letters. I want you to write your first name, nice and bold, at the top of the page. Write your first name, all capital letters, at the top of the page. And if you will do that, I will give you extra credit on the notes. Please don't tell anyone about it. They have to watch the podcast for themselves. Okay? If someone's copying notes, they won't notice. And only you will get the extra credit because you actually listen to the podcast. I'll see you next week.
Made with Doodlecast Pro.